Assalamu alaikum dear students. I'm your host Mohammad Nadeem. Today in this lecture we will discuss Shapiro reaction. Shapiro reaction is Tosyl hydrazone decomposition. This Shapiro reaction was first discovered by Robert A. Shapiro in 1967. Shapiro reaction involves the conversion of aryl sulfonyl hydrogens of aldehydes and ketones into olefins by reacting with alkyl lithium reagent or Grignard's reagent or alkali metal amide. This reaction is carried out at a temperature of -78 degrees Celsius. This reaction is similar to Bamford steam reaction where bases such as sodium methoxide, lithium hydride, sodium hydride, sodium amide, etc. Another major difference between the two reactions is that the Shapiro reaction yields less substituted olefins as kinetic product, the product that predominates when the reaction is done at lower temperature, while Bamford steam reaction yields more substituted olefins as the thermodynamic product, the product that predominates when the reaction is done at high temperature. When we talk about the general reaction of this Shapiro reaction, we can see here that aldehyde or ketone on treatment with tosyl hydrazine, they form tosyl hydrazone. This tosyl hydrazone on further treatment with butyl lithium or benzaldehyde or DMF, they form alkenes. Tosyl hydrazone is a functional group with the general structure RR C double bond and single bond NH single bond TS, while TS is a tosyl group. Tosyl or toluene sulfonyl group with their molecular formula CH3C6H4SO2. This is used as protecting group for alcohols and amines. Protecting groups are introduced into a molecule by chemical modification of a functional group to obtain chemoselectivity in a multi-step reaction. When we talk about the chemoselectivity of the reaction, chemoselectivity is the selective reactivity of functional group in the presence of others. Mechanism. When we talk about the mechanism of this reaction, here we see that there is a in first step there aryl sulfonyl hydrazone, here first equivalent of butyl lithium abstracts NH proton to produce unlithiated species. After that, second equivalent of butyl lithium abstracts CH proton to produce dianion. Here, the elimination of toluene sulfonate occurs to form an intermediate. After that, we can see here that there is a generation of alkyl lithium intermediate and also the liberation of N2 gas. After N2 liberation, there is a formation of alkyl lithium intermediate which can further react with a variety of electrophiles to form alkene or its derivative. After that, when we talk about the regioselectivity of Shapiro reaction, here you can see that aryl sulfonyl hydrazone on deprotonation with butyl lithium, they form unlithiated species. This unlithiated species form two main substituents. Yeah, two substituents. One is more substituted and another is less substituted. But according to Zest's rule, Zest's rule, less substituted is less preferred and more substituted will be more preferred product. Asymmetrical, highly substituted enoliths are here thermodynamically more stable. When we talk about the synthetic applications of this Shapiro reaction, you can here see that synthesis of an allylic alcohol, which is an intermediate in the synthesis of maquetizine, which is an H1 antihistaminic used to treat allergies and rhinitis. Shapiro reaction is involved in the formation of ring B in nicolotaxol total synthesis. Another synthetic application of Shapiro reaction is that a class of chiral Indians जिनको हम verbidians भी बोलते हैं was prepared from verbenone by utilizing Shapiro reaction as one of the key transformation steps. Here you can see the structure of verbidine. Thank you for today's lecture.